Hello and welcome to Automation Talk, and we thank you for joining us today. As you can see, and you signed up for it, we're going to be covering our pneumatics, and this is Automation Direct's line of pneumatics, and it's called NITRA Pneumatics. And we started out with a couple of small product lines with the pneumatics, which was tubing, some fittings, and so forth, some cylinders, and we have grown that very rapidly, very largely, and we're still in the process of adding more. So we'll explain a little bit about what we've got so far, what we're going to add to the line, and just tell you to keep your eyes open, and we'll hopefully grow this line pretty quick. But we have some really cool stuff at really low discount prices.
Well, we've kind of held off on putting this together for a little while because we were waiting to get a full functional line of products where we could actually start talking about pneumatic systems with the solenoid valves and flow control and all the air preparation type builders and equipment you might use. So we're going to jump right into it. We got a lot to cover, so we're going to try to make this as rapid as possible today.
Which never happens.
It never happens.
We're going to cover all the products that we've got, and then Tom's going to go over maybe some applications and whatnot, and also if the guys can show the video, if you can show the camera over there at our little demo rack, we've actually got a demo, and it's a full automated demo that Tom built, and we'll just basically turn it on, let it go through its cycles, and explain to what he did and how he did it. And of course, this isn't really a cool application as far as a
it's not a real world application, but it's entertaining.
Yeah,
maybe
there you go. Hey, maybe you could sell it and make some money.
The main purpose of the demo was try to integrate all the different products so we can use them all.
Right. All right, so first off, you can see on the agenda we're going to go over the air prep, the directional control, cylinders, the position switches, the fittings, we've got flow control, tubing, and then the accessories that we've got with this. And some of the accessories we'll sort of cover as we're getting to each of the individual lines. First, I'm going to let Tom talk about the safety tips, and I'm actually
Number one, safety. You're dealing with pressures. You might be looking at 30 psi all the way up to 120 psi or even higher. So number one is make sure whatever the application is or the equipment and the compressor or however you're sourcing your air pressure, is within the it doesn't exceed the maximum ratings on the different devices. Cylinders might be rated at 120 psi, the valves at 150 psi. Some of the fittings are at 120. Flow controls, everything's a little different. So you need to look at the entire application, and then along with that, make sure if you're working on the equipment after it's up and running, and you're going to make some adjustment, change something out, you need to really shut the equipment down. We have a real nice manually operator pressure relieving valve. Shane happens to have it in his hand there. With some of the other, we call them FRL, or air preparation products for filter regulation and lubrication.
Right.
And then also, practice lockout, tagout. And then one step further, there's always, even if you shut off the main valve and lock it out and take pressure off the system, and there's always going to be some accumulation of pressure in some cylinder or something. Make sure you take a hard look at the equipment and bleed that pressure off. So we'll let Shane jump into, if you want to go to the...
Yeah, hang on just a second. With the nice little shutoff valves that we have, they actually come with a nice little key lock and
couple
the
keys.
And I mean, it's a step. It's not, it works. It's not a master lock, obviously, but it's better than what you get with your luggage.
Yep. And for sure it's going to make somebody walking up to the equipment, if you're working on it, to give a second thought before they try to turn it on.
Well, like Tom just talked about, it's the manual shut-off, as you can see on the slide there, and I'll go ahead and hold this little demo here I've got, and also we'll probably refer to the demo rack here in a minute with some of the stuff. Tom used some of these same products, but we have these components. Basically, you can buy these components and you can use them individually, and at both ends of them you can attach fittings to them. So if you don't need all the maximum components here, you can see on there it's got a little red plug. The one I've got here has a blue plug, but you can get fittings. So you could use just this shut off. But what we've done here, and also on the rack, and I don't know, sorry guys if you showed that, then thanks. If not, then you can go to that camera. We basically built a whole system here and created a manifold. In doing so, I've worked with a couple of different manufacturers of pneumatics over the years, and I'd have to say this is probably the easiest one I've ever assembled. They come back to this camera shot there. Yeah, there we go. It's a little bit hard to tell, but this is a attachment plate, and it's a mounting bracket. On the inside of it, it's got O-ring made into it. So basically, you just put it in between it, and when you tighten the Allen screws down, it clamps the whole system together. I mean, it was really easy to put this together.
And those mounting brackets come into in 3 different configurations with 2 tangs, 1 tang, and then a plain one that allows you just to bolt the thing together.
Right. As you can see on these, all of these pieces and parts we carry from the 1/8 inch up to half-inch NPT. Some of them go even larger.
And you'll notice as we go through some of the slides and everything, we've tried to incorporate the symbols for the different pneumatic products and everything that really help if you're actually going to design a full system, to use those symbols to actually make yourself a pneumatic schematic.
Next up, pneumatic schematic. All right. Next up is the air filters. And as you can see, again, 1/8 inch. These actually go up to 1 inch. They have the replaceable filter element. They come with a 40 micron. And you said you can get up to a
well, they come with a 40, and you can replace that with a 5.
Right.
5 micron for real precision type applications where you can't afford to get any kind of particulate matter into your system.
As you can see, the one on the slide and also the one I've got in my hand is just the filter. And these are nice even in just home uses on your air compressors. I mean, it's going to save tools and stuff like that, getting any type of contaminants in it. I've always put these on any of the systems I have when I have time.
Has also a drain plug on it,
yes,
too.
Has a drain plug. The one I have here in the manifold actually has the pressure adjustment on it. You've got
combo unit?
Yeah, it's a combo, so it actually has a gauge built into it. You've got your regulator on it, and you've got the filter on the bottom of it. The next is just the air regulators themselves. I don't have one of these on my hand. Tom used one in the demo down there. I just bought the combo unit. It saves space and time and might save a couple bucks. You'll be surprised at how cheap these things are. As far as price, they're really inexpensive. And like I said, I've worked with several name brand ones, and I was really shocked at when I bought these, what the price was. I was like, wow, I was expecting them to be about 3 times that price. And when I got them in, we'd already played with them a little bit in training, but they're really nicely made. Air regulators, anyway, you can get them just the individual air regulators. Those work on any type of systems. Again, even if you have a home system, you could use the air regulator to regulate the whole system. And as you can see, 1/8 up to 1 inch NPT. The air filter regulator, that's the one we just talked about basically that I have here in my hand.
Unit.
Yes, the combo unit. And the last one is going to be the air lubricator, basically an oiler is what it's going to be. You've got an adjustment on the top of the oiler, and as you can see what I've got in this one in my hand, I've got the shutoff, I've got the regulator with the filter on it, and then on your output side is where you want your lubricator. You don't want to have the lubricator in the front because you're basically going to clog up your filter if you do that. Yeah. And not all systems need lubricators. Now, if you're using air cylinders and whatnot, you definitely want to add a lubricator in because that's going to extend the life of your cylinders. Places you don't want to use a lubricator is where you're using some type of painting application because you're going to squirt oil through your paint guns, which oil and paint just doesn't mix too well.
Don't mix real well, no.
But they work great for air tools, pneumatic tools and stuff too, though.
And actually on our demo panel and everything, I did, put a lubricator in there, but in our case, because it's inside the studio here, I didn't put any oil in there. And as often as we're cycling it, it's doesn't really call for oil.
One key point we didn't mention, Tom brought up a while ago, is you can actually refill the oil while it's still pressurized. Yeah. You don't have to turn everything off.
You don't have to have downtime to
That's good
add
for maintenance.
Oil to. Exactly.
Okay, the mounting brackets, like I'd mentioned that about the mounting brackets, how nice these were. Tom said, you get the 1 tang, 2 tang, and just the mounts, and then also the filters that we sell that are extra. Applications.
We'll talk a little bit about applications. As you see on the slide, packaging, machine tool, pulp and paper, food processing, material handling, animation, robotics, pick and place type units, and of course, automotive manufacturing. A lot of pneumatics are used. I should mention real quick off the top of my head, pneumatics is air, it's compressed. There is some give and take, and I'm just going to throw this out. We don't sell hydraulic cylinders at this time, but in your application, everything, there's a ton of applications that pneumatics are perfectly suited for. Although there are some applications where you're probably going to have to use hydraulics for higher forces and probably better speed regulation in some cases. And
but pneumatics are going to be cleaner and cheaper.
Exactly. Yeah.
Some of the applications, Tom, what have you worked with in the industry?
My main thing with pneumatics, with my electrical system control background and everything, had to do with material handling. So I did a lot of things, and part of it I actually put into the demo, but the particular products we were manufacturing, everything, were going from machine to machine, so we had material handling systems in between, and we had these chutes that the product would roll down, so I had to build and design a lot of escapements to sequence the product into the machine for the next operation, so it was one piece at a time. Also, a lot of the process in the equipment we were doing, or the product we were manufacturing, everything had different measurements and tests. So we might look at the product if we were heating it up to make sure it was up to temperature. We might gauge the product to make sure it was the right size. So as the product was sequentially going through the process or the machinery, if we found a part that was bad someplace in the operation, we had to keep track of it. And as it was rolling down a chute or something, we might have a cylinder there that would kick it out into a reject bin. But that pretty much sums up my pneumatic experience.
I used I used to work at a manufacturing facility that made jewel cases or CD cases, and we were the largest in the world. We had several plants, but yeah, the machines that actually brought the CD cases, it was the top and bottom of the clear trays, would come out, and it would basically snap them all together, assemble them, pack them in 25 or 50s, and wrap them up and set them on a conveyor. And it was quite impressive because there was probably, I'd say, at least 20 to 30 pneumatic cylinders, just popping away all the time.
Like an assembly type operation?
And cool. Running 24/7. And also something I have to bring up is we actually did this here. Haunted house that we created one year. We used some pneumatics, and we found out we actually have a lot of customers in the entertainment industry, especially in Halloween type development, that build controls and stuff that use our PLCs and whatnot. But there's a lot of pneumatics in the Halloween stuff. But yeah, we built some stuff here at Automation Direct, like some drawers, dresser drawers that would open and shut with pneumatics. And at the time, we didn't sell these. This was 10 years ago probably. Right. Yep. I was buying them off of eBay, and I was paying for used cylinders same price as what we're selling new ones today.
I remember helping you with that a little bit and everything with the some of the cylinders we couldn't even use because they weren't working.
All right, directional control solenoids.
I'm going to shift down here and everything. I'm reading words and everything.
All right, Tom's going to talk about the solenoid valves, and I'm just going to sort of punch through the slides. So first up, he's got the directional controls. Now those are what you said called like poppet?
Well, we have basically these break down into two different types. The first one I'm going to cover is a poppet style valve. The other series of valves in different configurations are referred to as spool valves, and the difference is the poppet valves is like a small orifice with a rubber seal that comes down and opens to let the air through, and the spool valves, of course, are a spool that shuttles back and forth that has ports, or I shouldn't call them ports, but openings through it that line up, and there's O-rings inside the valve and everything, but it lines up with the different ports. So the very first one we're going to get to, if you want to go to the next slide, is basically our 3-port 2-position. We call them the AVP series. It's a poppet valve. They come in 1/8 NPT threads. We say they are 2-position 3-port. Now, what's going to throw you off, this one I'm taking apart because I want to demonstrate if we can get a close-up on this. We also sell a mounting bracket. These are stackable. And the mounting bracket comes that we can, I don't know if you can get close into this or not, but the mounting bracket, there we go, allows you to mount this on a panel or a subsurface. It has 2 screws. And then the thing I want to explain is, we have one port here. It's labeled A. That's actually would be the output that you would take to a cylinder. In this case, most of the time you're going to use a single acting cylinder where the cylinder only has one port, and generally it's going to be spring return. This also, because we can stack them, has a port here and a port here. Those together are the second port. Those are the pressure port. That's where I bring pressure in. This, if you could see it, goes all the way through. So where's the third port? There's actually a third port. I'll call it the exhaust port. It's actually through the knob. There's a tightened down knob that actually holds the solenoid onto the valve spool. And through that valve spool, it's hollow, and it actually exhausts through a small hole in the knob. So there's the basic 3 ports we're talking about. Very simple. They're available. All the valves are available in 24-volt DC or 120-volt AC. To stack them, since we're still on that close-up, or back to the close-up, there's a kit you can buy, and the kit consists, you can see in the picture, of a series of screws and an O-ring, but 2 of the screws you actually place into the mounting holes in the valve and tighten that up, and then you take the O-ring, you place that into the recess, and then you can take your second valve and place it, oops, if I get it the right direction, place it on top of it, and then there's another series of screws that basically, I shouldn't say basically, they always go in, and you can tighten them up and secure it. So I can go, I don't know if there's a limitation on this, but I can keep stacking the AVP type series valve up as far as I want to, and control lots of different things. And we'll talk a little bit about the wiring and the built-in LEDs that are in the connection plug that are on each valve. And if you want to go to the next slide, we're going to talk about the 3-port 2-position valves, and that's going to be one of these guys. This can sit on a manifold. Actually, I'm sorry, this one does not have a manifold. These are individual ones. They aren't stackable. Same principles. They're 3-ported, 2-position. But in this case, these are the nice part of them. And let me jump back to the poppet valve. There's a manual override on the poppet valve. It's hard to see here, but I can push this in and actually manually operate the valve. On the next series of valves, the AVS 3s, there's a red push button, little red push button here. And let me bring this one up. It's easier to get to, but I can push that down and operate the side of the valve. But what's really nice, I can actually push it down and then with a screwdriver turn it 90 degrees and lock it in. So if I'm trying to troubleshoot a piece of equipment, I have a means to manually override the electrical controls on the valve. The AVS 3 valves, they're body ported, of course. They're available in an 1/8, 1/4, and 3/8 MPT. They're 2-position, and they're available in a single solenoid, and they're also available in a, that's not one of them, but they're also available in a double solenoid. If you go to the next series, now we get into a 5-port, 2-position, and that's one of these guys here. And the big difference on this is you look on the bottom, you actually see the center hole here is used for the pressure, and then there's 2 exhaust ports, one labeled R and S, and then on the top part are the ports that actually go to the cylinder, and they're labeled A and B. These are available in either a single solenoid, and which again, I do have one. A single solenoid, spring return, or a double solenoid, which is this one. The next series we get into are our 5-port, and this is one of the valves that I actually used on the demo to operate the large 2-inch bore cylinder. But these are available in both. They're all double solenoid. They're available with a closed center position or an open, and I'll explain that a little bit when we get into the demo, what that can do for you in choosing either the closed or the open. And I should mention, back on the other valve, hopefully I did mention that there are manifolds available. We have them in the 52 series or the 53 series. They're blanking plates. We'll show a slide of that. But what's nice about this, I can buy these manifolds in either 2-position, 4-position, 6-position, or 8-position. So it eliminates a bunch of piping and between valves to get my pressure to the different valves and then out to the different cylinders I'm going to use. So next slide, a little tip here. I threw in some tips today, and this one I'll try to explain real quick. What you're going to see on the valves is a flow coefficient. And basically what that tells you is, how much air I can get through that valve and how fast. And, there's always an orifice or a restriction built into the valve. And what that says, a coefficient of 1 means if I take 200 psi and flow it through a valve that has a coefficient of 1.0, that means I can get something like 100 static cubic feet per minute of air through that valve. So if you get into all the calculations, which we're not going to get too deep in calculations today, that's going to tell me how fast I can get air to that cylinder and how fast I can move it and how much load I can carry with that cylinder or move something with that cylinder. And if you go to the next slide, the other thing we want to mention, especially with the solenoid valves, is they are an inductive load. And we, again, sell them in 24-volt DC or 120-volt AC. Dealing with inductive loads, if you're going to tie these into a solid-state output, such as a DC output module you'd find on a PLC output card like we did here with our Click PLC, you definitely want to put some kind of surge suppressor across that inductive load so the kickback, when it's de-energized, doesn't destroy the output transistor or MOSFET that's firing into that.
Yeah, maybe if we've got time, we can rotate that around and actually show them the diodes that we sell.
Okay. And we show on the slide there the part numbers. Even on 120-volt AC, if you're using a triac type output module, still a good idea to put some kind of surge suppressor across the inductive load. You go to the next slide, we kind of talked about the manifolds, and again, the cover plates. There's 2 different size manifolds in 4 different sizes, and there's cover plates that allow you to block the ones you aren't using. I should mention real quick, if I set this manifold up, I'm going to bring pressure into, let's say, this center hole. These are set up so they're straight through, so I could actually take manifolds and pipe between them and keep stacking them up. In my case, if I'm using a manifold like I did on the demo, I definitely want to put pipe plugs in one side, bring my pressure in the other side. Then on the other end, I'm also going to have a pipe plug because I'm not going anyplace. And then I definitely want to put some kind of exhaust mufflers to cut down the noise and whatever other type of situation I might run into. We currently have on the books to come out with the, right now we don't sell the exhaust mufflers, but they're coming up.
You can see a picture there if they'll go to the camera. There we go.
Yeah, those
Down
are
at
the
the bottom,
2
we've got
brass-colored pieces hanging on the bottom there.
Yeah, we don't carry them, but
they're
everything.
Coming up.
Yeah, we've got many products in the line for to
Pneumatics.
launch for the pneumatics line. All right, we're going to talk about the cylinders, and I'm just going to briefly hit these because the biggest thing is we do carry cylinders. We've got a couple different styles, and we've got a lot of different shapes and sizes. And the best thing to do is go out on the website and take a look at them, and you can actually see the printed prices there. And if you've never been on our website, what you see is what you get as far as the price goes. Sizes, you can see we go anywhere from 7/16 up to a 2-inch. Different lengths, different styles. They're stainless steel. One of the biggest thing is these are made here in the U.S. These are private labeled for Automation Direct, and they're going to be comparable with top manufacturers of air cylinders. I don't know what else to say about them other than, like I've got several of them right here. Tom used one of the larger ones like this.
I think right now it's the largest one we currently sell.
Right. On the demo, we've got, some shorter, they're large diameter but short, lengths on them. Anything down to the smaller ones. We've got different styles of mounting for these, which we'll cover in just a second.
You mentioned single acting, double acting.
No, I didn't. Single acting and double acting. Difference is say this one here is a double. It actually has, it's hard to see here, but actually has input and output controls or ports on this cylinder. So you're going to pipe in air on both sides, so you can control direction of it in and out the cylinder itself. On a single, I don't have one here on the table. I do have one up there on the demo. Yeah, there's. See if they can go to that
one up there.
Picture.
You go up on the demo. There's a
there we
small
go.
one. Yep, that's it.
That one, if you can see, it just has one airflow in, and it's a spring-loaded return back out. All right.
Okay. You might want to mention real quick with the cylinders, because we sell sensors to sense the position. They maybe you mentioned that
Not
they
yet.
come in mag and non-mag variety.
Right.
Magnetic. Variety.
And we'll explain that why when we get to the sensors.
Okay.
More on the pneumatic cylinders. You were going to talk about actually that's another slide, isn't it?
Yeah, the force. Just a real quick tip and everything. We have different mounting hardware for the cylinders and different clevis pins also for the cylinders.
Yeah, as you can see, most of the cylinders they're going to come blank, but I have here. You've got different types of ends for the cylinders. You've got different types of mounts. Most of them you can get them with threaded, or they come with pins or holes on the ends of them. Tom will show you a little bit better what we got over there, what we mounted up. And typically, it just depends on your style, your piece of machinery, if you're just replacing one or you're actually building one. We didn't have a mount for the that little single acting cylinder. We just made up our own little,
Shane whipped up
fabricated a little aluminum bracket for it. But, they're fairly easy to mount and fairly quick to mount. So.
This is the last thing we'll talk about with cylinders right now, but the next slide after the mounting hardware and everything, real quick, just another tip and everything. You have a cylinder, it's a piston inside, one end's a rod. I mean, they do make cylinders with rods coming out of both ends. You're going to apply pressure to it, so if you're putting 100 psi on it there, and you figure out the cross-sectional area of the actual piston inside the cylinder, you're going to be able to figure out how much force you can exert with it. Just a tip, keep in mind that when you're extending the cylinder from what I call the blind side, you're going to have a certain amount of force if you calculate it.
Right.
On the return side, if you're trying to pull something, keep in mind you have that rod there, and that rod actually takes away from the amount of cross-sectional area, and therefore you got less, when you retract, you're going to have less force to retract with. And it's just something, if you're going through all the calculations to figure out your application, keep that in the back of your mind.
Here's a good example. Let's just say we're going to take this cylinder, and we're going to use it to lift, say, a maximum load, whatever it is. Let's just say throw out 200 pounds. So it's going to lift 200 pounds up easier than it would pull 200 pounds up.
Exactly, yes. And in our demo, you'll see we're lifting some 1-inch diameter steel balls, but they really don't weigh that much. So.
All right, cylinder position sensors. Like Tom mentioned just a second ago, we'll back up a little bit. All of the cylinders you can get with magnetic or non-magnetic. The difference is if you're going to have cylinder position sensors mounted on the cylinders, then you're going to need the ones with magnets on them. Now, in the past, actually there's some people that still sell these, but there was two different types of cylinder sensors. There was an old type called reed sensors, or reed switches, and it was basically a mechanical sensor that had just a little toggle metal flap inside, and the magnet would pull it down. Well, after a while, those little tabs would get magnetized, and we saw this a lot on the assembly machines, and basically keeping the machines running, we'd have to go over there and pop them with a screwdriver, and they'd sort of release, and the machine would keep running. They just wouldn't let us shut them down. Well, then they came out with Hall effect sensors, and these are solid state. There's no mechanical devices in them, and that's what we sell here is the Hall effect. So it's going to pick up the magnetic cylinder as it reaches whatever end you've got it mounted on. These that we sell, they have the LED indicators on them. You can mount them on both ends, or you can mount them on one end, or you might not need one at all, so you can go with either the magnetic or the non-magnetic type cylinders. The cable types, you can get them with a pigtail, which already has ferrules on them, or you can order them with the M8 connectors, like we sell with all of our standard sensors.
We sell a mating connector for that.
And we sell all kinds of cables with pigtails on them. We sell extension cables and whatnot for our sensor line, so you'll find those.
There's also the sensor mounting hardware. We sell that in various sizes with a stainless steel clamp and then a plastic ferrule that actually holds the switch. And real quick, I didn't want to get too deep in this, but you'll notice on the slide that we use an AMR sensing technology. Basically, what that stands for is anisotroptic magneto-resistive. Versus, in most cases, some of our competitors, they use a GMR, which is a giant magneto-resistive type technology. The reason we went with the AMR or selected that for our choice was that offers more sensitivity, and in the long run it has a lot better repeatability. So if you see that in our literature, AMR, that's the type of sensing that we're using for our sensors.
Okay, cool. I'll see if I can remember that tomorrow.
Yeah. Don't ask me to say that again. Shane's going to talk a little bit about fittings.
Fittings. We actually had a customer ask a question. I was going to try to hold off to the Q&A, but it's a pretty good one. We'll cover it again in Q&A, but I'm just going to mention it through here and see if that answers some of the questions. But our push-to-connect fittings, we have, Tom has 2 pages there, but we've got, as you can see, the bulkhead unions, straights, reducers, T's, elbows, Y's, union crosses, union triples. And you see all the little pictures. Pictures on those slides are going to look a lot better than what I've, me showing you in my hand. I've got flow controls here, which actually, see if they can show that with my nice little Christmas story shirt on. Anyway, these are flow controls, and the one I have here has a red end on it. And the red end indicates that it's a 1/4-inch tubing fitting, and this mounts into a cylinder, end of a cylinder.
It's already pre-coated with a Teflon type tape for sealing.
So flow control. I've got, see, there you go. I've got a blue one here. This is a T fitting, and the blue indicates that this is a metric fitting for metric tubing. So it says an 8, so it's an M8. We carry all types of T's. We've got push to connect flow control. We've got some Y's with, you've got different sizes. This one's a 3/8 in, and it has a a 1/4-inch out. I've just got a whole list of, we've got sort of like
bulkheads.
Yeah, bulkhead push to connect. So if you're going through any type of panel or machine, you can do that. We've got, this one.
Little manifold?
Yeah, it's basically a manifold. It's in and out with one size, comes out with 3 more in the middle. You can get different sizes like that. We've got manual shutoffs. It's just an inline push-to-connect manual shutoffs.
Those are really good if you're setting up a machine and you need to isolate something while you're troubleshooting.
Basically a quad.
Yep.
4 in. You've got 90 degrees. So we just have, a full line of all these. This is actually a check valve.
It's a large one.
Yeah, very large, but check valves. So, I mean, there's a lot of stuff there. Let me hit the next. Yeah, it just sort of goes through the rest of it there. But there's a huge selection of the push-to-connect, the fittings and whatnot. And you can take a look at our webpage with all those. Also, we've got the plugs and whatnot on those as well.
And should mention, too, these a lot of the fittings are not only offered in different tube sizes for the tube we sell in both inch and metric.
Yes.
They also have different threads. So we have National Pipe Taper. And then what threw me off, because I don't think I've ever ran across it, is a BSPT, which is the British standard pipe taper. So we sell them in both flavors, if you want to look at it that way.
Yeah, like I've got, and I've got 2 different. Yeah, we have multiple sizes. I forgot to mention that. It's several different thread sizes as well as the tubing connector sizes. All right. air flow control valves. That was basically what I showed you there. We've got the the push connect on both sides, so it's an inline. Then you've got the ones that fit on the cylinders themselves.
The meter in, meter out. And if you go to the, we don't need to go through all the. I mean, a lot of the fitting details. They're sized and threaded, just like the other fittings. But if you go to the next slide, we want to talk a little bit about meter in and meter out. And I'll try to make this quick. With the flow control, you're either going to meter in or meter out. And what that means is there's actually built into the flow control a needle valve that you can adjust to get your flow rate through. So in one direction, your air is actually going through the flow control. In the opposite direction, it's going to bypass or go through a check valve. So if you look at that one picture with meter in, with the flow coming in, it'll go through the actual airflow will go through the needle valve into the cylinder. When the air's coming out of the cylinder, it's actually going to push that little ball in the check ball out, and the flow will actually bypass the needle valve.
Right.
So what's all this mean? If you look at the other diagram with the 5-port, 3-position, center closed valve, you'll see A and B. You'll have to picture pressure coming into the P port, and then schematically you'll have to picture either the right side being in the center or the left side. This is a double solenoid spring return valve. And what you'll see is if I bring my pressure over, so I'm bringing the left side over, so therefore my pressure is coming out of A. And B is going out through S, which would be an exhaust port. We'll probably have a muffler there. Actually, on our demo, we do have a muffler. And what you'll notice is my flow is actually going into that top metered out valve, and it's going through the check valve. So there's no restriction. But if you come down to the bottom, there it's going to be blocked by the check valve, and the flow is going to go through the needle valve. So I'm actually metering the air that's in the bottom of that cylinder out. Why would I do that? The reason is why I would use meter out. If you picture that cylinder and I put a weight on it and I use meter in, the meter in is going to allow the air pressure in the bottom to push on through. I'll have very little control. If I mounted that cylinder horizontally, right, laid it on the table, then I wouldn't care if I was using meter in or meter out. But if I'm going to put any kind of load on the cylinder and mount it up or down, then I definitely, for those applications, I need to use meter out only. And if I'm using an inline flow control valve, I'd want to make sure I orientated it so I was actually metering out as it moved. Hopefully it's kind of a rough explanation, but with pneumatics, I mean, if we were doing hydraulics, we wouldn't care.
Right.
You can't compress hydraulic fluid.
Sure.
Air, you can compress it, so it makes a big difference. Hopefully that's a good, get you where you need to be.
All right, now we're into the last section here of products.
Tubing?
Yeah, it's going to be tubing. I think that we've got a couple accessories after that, but the tubing, we've got 2 different types of tubing. Tom's got little examples over there with him, which is the well, we got 3 different colors. We got different sizes in standard and in metric, and you can get these in different lengths in the 100-foot and 500-foot package sizes. And this is the PUR, which PUR is typically good for if it's going to be exposed to sun or UV, whatnot. It'll keep it from hardening.
It's stronger. I mean, the other one we offer is nylon, so the polyurethane is stronger.
There's the nylon.
Yeah, there's the nylon, but it's a little more expensive, of course.
Which one is?
The polyurethane.
Okay.
So if it's a little better as far as rigidity and kinkability and UV thing, it's going to be a little more expensive. It's a little more flexible than the nylon too. So we offer the 2 grades, polyurethane and nylon. Okay. Size-wise, I'll pull up my catalog book that I'm going to reference later, but size-wise, we offer the smallest here in diameter is the 5. I can get this blue stuff. We offer it in 3 colors too: clear, black, and blue. We have some other offerings coming out out shortly in the next couple months or so. But the smallest is 5/32, which is also designated as 4 millimeters. So if you're buying fittings, this tubing is going to work whether it's the 4 millimeter or the 5/32 type fittings. And then we also order or offer a 1/4 inch, 3/8, 1/2 inch, and then in the metric sizes we go 6, 8, 10, and 12 millimeters. But that's all in the catalog. We're going to reference the, there's 126 pages in the pneumatics section of the catalog that has a wealth of information to use. So from the tubing we go into our accessories.
Yeah, there's not a whole lot we haven't covered on the accessories. You know, we talked about the mounting for the sensors, for the cylinder sensors, and then also the only other thing is this nice little handy tubing cutter. And if I can get the guys behind the cameras to, they're back there arguing. I'm waiting on a fight. We'll turn the cameras around then. No, I'm just kidding. Now we have these nice little tubing cutters. Could I use this on my cigars? Nah.
Possibly.
But no, these make life a lot easier with tubing cutters. I know in the past I always tried, try some side cutters. A lot of times you can crimp. Basically, it ends up crimping the actual tubing. There are some nice little tube and hose cutters that, say some of our, not ours, but some tube manufacturers or tool manufacturers make. But yeah, these work great for just.
You want to demonstrate?
Yeah, I'll go ahead and demonstrate. Yeah, just got a nice little V on here. You can just lay it down in there, drop the razor blade on it. Don't put your finger in there and snap it right off. Nice clean cut. So it doesn't get any easier than that. And these are really inexpensive, so it makes life easier.
Those were kind of I don't want to say a second thought, but somebody brought our attention to their availability, and we thought, hey, we're going to carry those and sell them and everything. The last thing we're going to get into is our demo. And we're going to try to, if you get Shane up here, and what I want to try to do on the demo and everything, we're actually using a Seymour Micro at the top there to basically do two things. One, we can actually manually operate the solenoids that control the cylinders, and then we can also put it in auto, and with some sensors that we have sensing the steel ball, we can actually automate the system and have it circulate the balls. I'm
going to go ahead and turn it on while they've got a nice shot of the Seymour Micro.
And we're using a Click PLC to actually do our logic, and it's a very simple application.
As you can see, they've got it on the Seymour Micro, but we can select between manual and auto. Tom did all the programming on this, but it was already in auto. We've got it in a stops cycle right now. I'm just going to hit start, and then I'm going to back up and let Tom tell what it's doing. And
very simple design. We have some polycarbonate tubing with 1-inch steel balls. We have our 2-inch, 18-inch stroke cylinder with a little tool application on top, lifting the ball up. When it reaches the top, we actually have both sensors on the cylinders to tell us when we're up and down, but we also have some proximities to tell us the ball's in position at the downstroke, and also at the top stroke we tell when the ball's up there. That gives us a signal back to the PLC, of course, and we use that through a time delay to trigger our poppet valve, and the poppet valve controls that little single action spring return cylinder at the top that pops the ball out. The ball travels down through a couple twists and turns and it lines up with some other ones. There's also an escape, and I alluded to the fact that a lot of the material handling stuff I had done in the past, we had various escapements to sequence the product one at a time. So what you're seeing there is we actually, when we get up to the top, we stage the next ball, and then we bring up our stop, and when we get to the bottom, we release it. So it's a double, those cylinders, actually they're very small. I think those are 7/16, maybe they're 9/16 cylinders with a 1-inch stroke. They actually, it's hard to tell on the video here, but there's actually sensors on it. You might see the orange LED on the sensor flash every now and then. So, and that's our poppet valve at the top that's going to take the ball and pop it down. So, very simple control scheme. We're just moving balls around, but what this allows us is to actually use, both double acting cylinders, single acting cylinders, poppet valves, spool valves, the large cylinders being controlled by a 5-port, 3-position blocked center solenoid. And actually, Shane, if you want to throw it back over into manual, what this block center I alluded to will do for you is we can actually jog. If you get back over to Shane, he's going to jog that 2-inch cylinder up. And if he lets go of it, it's going to stop and hold. So you can actually position that cylinder by that valve by up and down. And our little machine here, we actually have it set up so it has to, the starting position has to have that cylinder down with a ball in position to put it in automatic. But Shane's also able to bring it all the way up to the top manually. And then he has a poppet valve, or we'll call it the pop ball, and he can actually pop that ball out. Now he can bring the cylinder ball all the way back down. He can hit the stage button, and it's a momentary, so he has to hold it until the ball, and then he hits the release button, and that actually energizes the release solenoid and puts another ball into position ready for the next cycle. So we're trying to use all the elements, and if you pan down, you'll see, I think you've seen it earlier, but we are actually using a manifold. We're using a poppet valve. Then we're using there's the poppet. Then we're using a manifold with the double acting 5-ported 3-position valve, and then we're using 2 single solenoid 2-position valves, 5-ported also.
These are for the stage and release, and this one with the double is for the larger up and down control.
And then all the way down is our actual FRL, or air preparation equipment. So we do have a shut-off, the air filter, the regulator, and the lubricator. And again, I'm not using any oil in this system, even though there's some factory oil in the system that I had to contend with when I first hooked it up.
I want to show something real quick if we can. I'm going to try to rotate this, and I'm sorry, camera guys, because I'm probably going to mess up some view. And see if y'all can.
Now, this is a demo unit. It's a prototype. It's not something we typically would put in production. It's a regular 19-inch rack we used. So please, forgive us for the wiring. We tried to make it as neat as we could in
typically all this would be in an enclosure, but you can see what Tom did. He used some zip links back here, which makes life easier with, say, the Click PLC. And so he did all the wiring back here on the back side, whereas the front side's all nice and clean. But what I was going to show is pretty much the only thing I wanted to show is when Tom was talking about transients or spikes, which those solenoids will really create a lot of spikes, and it's anybody's solenoids. And typically solenoids and relays are going to be the 2 things that are going to cause it. There's major 2 components that would cause this. But he ran through one of these diodes, which is a zip link module here that Automation Direct sells used to. We just would send out diodes and you'd have to wire up your own stuff. But now you can see we actually have a nice little zip link module. So he ran these through there, which will keep those transient
out of the output of the PLC output module.
Yeah, and it'll also keep it out if you had everything wired into one system, which he did sort of isolate with 2 power supplies, so you don't have to worry about damaging input and output cards if you had any issues. But it's just something to think about when and if you do wire that kind of stuff up.
The other thing, all the cabling and tubing, I ended up using the polyethylene tubing on this. I just used the clear, so I'm using both 1/4 inch and 5/32 for some of the smaller valves. But I drilled holes through these aluminum plates on the rack, and I deburred them. But if I was doing this in real life, I would have put some kind of rubber grommets and everything, because on any type of application like this, whether it's the wires or tubing, through vibration, everything, eventually the metal to the rubber and vinyl and polyurethane contact would create little holes, and you'd be out there troubleshooting.
All right, we're going to go ahead and wrap up. Before we do, we're going to stop and take questions real quick. If you have any questions, I know there was one question, and I'm going to hit that real quick. Customer's asking, Stephen, he said, you're showing standard sizes in inches. Do we sell stuff in metric as well? Well,
Yes.
I went on, yeah, we do some of the stuff. Now, I jumped on the website real quick just to see what we had to make sure I wasn't miscommunicating. But you can go to our website, go to the pneumatic section. The cylinders are all in standard.
English?
In English, but also the solenoids, the control valves are. Where you're going to get into metric is when you get into the tubing fittings. That's when we sell the metrics. And then, Tom, you also mentioned one other thing in there. I forget what it was, the British.
Oh, with the threads,
Yeah.
any of the fittings are both, not all of them, but most of them are available on both the national pipe taper and then a British standard pipe taper. And you got to be careful because in some cases you're going to get one to fit where the other goes.
Right.
But you got to be real careful because if you use the wrong one in the wrong thread,
Cross thread.
well, it might not even cross thread. It might go in and feel great,
Really?
but you're going to lose your maximum pressure rating. You know, if you take an English 1/4 inch and use a British and put it in there, it's a little bit different taper, so you might not be able to get the maximum, you know, seal or torque on that thread, and therefore it might not operate at the rated pressure you want.
Okay. All right. We don't have any more questions. If you have any questions, ask us. If we go ahead and wrap up and you still ask them, we'll email you some answers. If we didn't answer what you were hoping for, or if we didn't cover anything you were looking for today, you know, shoot us a question. You can either email us or shoot it out right now before we close down.
Yeah, you're going to send them a reference, but there's 126. It's not in our. There's some of it's in our current catalog. But
Yeah, I've got the slide up.
okay.
I will send that out in the thank you email, and it just basically. But you can go out to the website and find all this stuff. It's really easy to find. Yesterday, I was on another manufacturer's website trying to see what brands they sold, and let me tell you, it took me 30 minutes to figure out under their terms of pneumatics where these components were at. It was such a pain. Our website is not like that. It is built around your request. We build it for you, the customer, but you can go out there and find pneumatics, and it breaks it down really easy. Every picture is there, the exact pictures, the exact descriptions, the prices are right there, what you pay.
Yep.
All right, we're going to go ahead and wrap up, so I'm going to get the guys behind the control booth to turn on the wrap-up music. Not rap music, but wrap-up music. So I want to thank Tom for doing the demo. He did a really great job, and thank everybody for coming.
Thanks, everyone.